It's time for pure performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello, everybody, and welcome to another episode of Pure Performance. My name is Brian Wilson, and as always, I have with me my co-host, Andy Grabner, who's here with the Davis AI figurine. And I just want to let people know, because this is audio only, Andy has not been mocking my intro lately. I think at least the last 2 or 3 podcasts, he's been being a normal human being. So thank you for that, Andy. And I think we can all have some gratitude. But Andy's playing with toys today.
Yeah, it looks like it, right? I don't know when I picked it up. Davis AI. I think it was the last. It was Perform. It was I think it was the Perform in 2020, before COVID. The last one before COVID, because the actress who played our Davis AI, she was also on site, if you remember, and we could take selfies with her, and then you could take what's it called, a bobblehead?
Yes, bobblehead.
Bobblehead, yeah.
Yes.
Yeah. Now the question is, why do I have this figure in my hand today?
Because you're feeling playful?
Maybe I feel playful, yeah. But really, because last week I had a chance to... Actually, I've been in Poland, and this is a true story. I've been in Poland, went to our office in Gdansk, and then in the evening got back to my hotel, wanted to go to bed, but then I always make, not a mistake, in this case it was a good mistake, I opened up LinkedIn, and I saw that 2 of our colleagues, actually 3 of our colleagues, did an Ask Me Anything session. And these colleagues were Gabriela Hassan-Birkenmann, Safia Habib, who moderated the whole thing, and our guest from today, Thomas Natschlaeger. And you talked about how we internally build Dynatrace Copilot, how it internally works, how we translate the prompts to DQL, how we train the model, and also how we test these model changes and how we, in general, deal with testing. And Brian, I thought, because we both have a big history and passion for software quality, I want to invite Thomas and learn about how we can make sure that the LLMs and whatever AI models we use, and also anybody uses out there, how we can make sure the results produce the right quality.
It's a very important topic.
It's an important topic.
Especially as we move a lot more, everyone's moving more into AI. And, just like we have to trust what our observability is telling us and all that kind of stuff, there's this trust factor with, is what AI is telling me true, right? And we've seen plenty of cases where, I'm not saying in the tooling, but in general, if you take a look at Copilot, Grok, some of these others, sometimes they just come out with these crazy either hallucinations or other things. So, it's interesting you said that. I don't mean to jump on this one point right here, but until you said that, I really hadn't thought about this idea of can we trust what our AI is telling us? So yes, I think it's really good. Please continue.
Yeah, and so with this now, I want to officially welcome Thomas Natschlaeger, Principal Data Scientist at Dynatrace. And if I look at his LinkedIn profile, it's really fascinating to see you spend a lot of time at the Technical University in Graz, then at the Software Competence Center in Hagenberg, and then you were at a machine learning engineer at Blue Sky Weather. So I hope you had a lot of blue sky predictions, because especially the last summers were pretty nice here. And now you're at Dynatrace. But Thomas, can you please introduce yourself to our audience, and then we'll jump into the topic.
Yeah, thanks, Andy, for the nice intro. Yeah, as Andy enumerated all the places where I've been working, you can guess that I'm not 21 anymore. So, and actually, sometimes I make the joke that I have written my first neural network in C something like 3 decades ago. So there is some experience in that area, and also my station at the university in Graz was about computational neuroscience and how the brain works. We tried to figure out some, let's say, theories about that, and that, as of today, comes in kind of handy to understand how all these layers in the brain work. And when you compare that to, let's say, all these convolutional neural networks and deep neural networks and stuff like that. So this early on knowledge in that area helps me to understand what's going on to some degree in all these large language models. Yes, and hopefully also back then the let's say the efforts we took at the university to simulate those brains and analyze that data to understand what it is doing, and also come up with some ideas how to test hypotheses for this large language, for this, back then it was called spiking neural networks, to come up with hypotheses for these. So everything ties together here nicely, and I think let's dive into this topic of testing those beasts, so to say.
Yeah. Before actually talking about testing, because now this is the way our podcasts work. We always get an idea and a thought, and then I want to talk a little bit more about this. You have been in this field for so many years. I actually remember it was in the early 2000s. I did not a master thesis, but I did what's it called before the master? Am I stupid?
Bachelor?
Bachelor. Thank you so much. Because I went to high school.
That's why you didn't get a master thesis, because you can't learn for bachelor's.
Exactly. Because I went to high school, then started working, and afterwards I did a bachelor degree while I was already working. And one of the things we did back then was in the early 2000s with somebody that you may also know, Ulrich Bodenhofer.
Yes.
He was my lecturer, and we did, for the bachelor thesis, we worked also on some machine learning algorithms to predict and calculate how to best steer a kind of like an autonomous driving car. And we were training the model with data on when to brake and things like that. So that was like 20 something years ago. And for most of us, and I think especially consumers of this technology, it feels like everything started like really 3 years ago because it became tangible. Can you explain from your perspective a little bit what has changed, and why did we all of a sudden see this? Was this a big, was this just luck, or was this, why all of a sudden was this big change where the whole world is now not only talking about it, but also using LLMs? What has changed?
What changed? I mean, it was really, let's say, some accumulation of, I don't know, events and long-term efforts, to be honest. I mean, the whole neural network community is working since the first neural network was invented in 1950 something by McCulloch and Pitts. And then later on, the groundwork for all this deep neural network stuff, there was this fundamental paper by Rummelhart and Hinton and guys in 1986 or something like that. And all of these papers actually were milestones and breakthroughs at that point in time. But due to the lack of, not having NVIDIA back then, right, it didn't make it into the public, because all these great ideas actually demanded lots of computational power. And from my point of view, the major breakthrough was actually already earlier in, let's say, in the late 2010s, when first people started to think about reusing GPUs, not for games, but for neural networks. Remember a colleague of mine, Horst Bishop at the university in Graz, when he came to me and said, look here, we are implementing variational autoencoders and a graphics card. And I thought, maybe a good idea. And back then, everybody had to do it on their own, making their hands really dirty with this really nasty, close to assembler code on graphics cards. Lots of bugs in there, also great opportunity for testing. Yeah, lots of bugs in this very low level code. And then this kind of evolution then typically is coming in waves, and sometimes there is a threshold and some emergent behavior pops out, right? It goes like this, like a baby when it's learning walking, right? There is a long time it's crawling around, and a few times it tries and suddenly it walks, right? It's not that it first can do 2 steps and 3 and 4, but suddenly it can do all of them. And that's the same in this evolution of neural network capabilities, when everything comes together, the hardware, the knowledge, the experience, and how to train them. And then in the computer vision area, this thing exploded around 2010, basically. And then people from the, let's say, large language, from the language modeling community, which mostly have been using kind of, hidden Markov models and whatnot to model language back then. At some point in time, we're looking also more and more into this neural network area, right? And then, like, let's say, starting at 2015 to 2018, one could already see that these language models evolved over time, right? And then there was this, I think it was 2018, there was this one big paper which is called Attention is All You Need, where researchers from OpenAI published the first transformer model. And then from there, it was like only 3 years on. And then, I mean, on Hugging Face, you could already have many of those transformer models back then. And then OpenAI just made business out of it. So baked it with big money, an easy to use API. And that's where we are now.
Oh.
It's really interesting, Andy. I never thought of that. It's stupid that I didn't know. There's no reason I shouldn't have known that AI has been being worked on since, what did you say, the 1950s with the first neural network?
Yes.
But I think I fell in the same trap of everybody where it's like, you just think it's a recent development. But meanwhile, it's been talked about for forever, right? Whether it's in science fiction or movies. Well, I guess that's science fiction as well. But yeah, of course it was being worked on. But it's not something I think any regular person thought. There is this tremendous impression that it just popped up out of nowhere. And things don't pop up out of nowhere. And it's been people working long and hard on this stuff. And I guess it really sounds like when the technology finally caught up to give it the powers, when it was able to finally make that leap. So just an interesting question, Andy. Thanks for asking that, because it makes me feel stupid for not even thinking that it existed. But yeah, of course it did.
I have maybe one funny anecdote, because there is this very well-known researcher in Switzerland, Jürgen Schmidhuber, and he is very famous, known to be, how to say, very exact when it comes down to which credit goes to whom, right? And he is always trying to find out what the earliest citation of some new invention, something like that, right? And in his opinion, all these kind of TensorFlow, PyTorch neural network machinery, which does all this learning and stochastic gradient descent, the real credit goes back to a student in Finland in 1970 or something like that, who first in time, according to his opinion, invented first time automated gradient descent for some autonomous control machinery or whatnot. So if you are that serious, the whole journey already started quite some time ago.
Mm-hmm. Yeah, and it's always good to look. The reason why I asked, right, because I was fortunate enough back when I did my thesis to work on this topic, even though back then, I gotta tell you, for me, it was interesting, but still it was so cumbersome to compile in our models and then to train it. And then the results were not that great. I mean, we had limited time, obviously. And then seeing what we do right now is just amazing. But, and this is now where I want to kind of transition over, when I now use these large language models, I'm still sometimes frustrated, because I ask the question and I get, an answer that makes sense. I ask the same question again, and then I get an answer that is not what I was expecting. And then I'm wondering, why do you give me two different answers for a similar question? What has changed? How is this even possible? And now kind of to how we are using LLMs, and with we, I mean the observability space, right? If you look at observability, I think every vendor now is basically saying, we have the data and we put our models on top, and then we get better insights and better answers to make sense out of the data, and you don't have to become an expert in analyzing all of this. I would like from you to know now, a couple of months or maybe a year or two in, on how we are applying this on our data. What are kind of the lessons learned, and what are still the challenges, and what do we do with testing to kind of improve the situation?
So before I jump into this whole testing thing, because I will refer to that sometimes. Mm-hmm. Basically, we have, I would say, what we call skills in place. And one is this more like a traditional, since 2 years, traditional chatbot based on a large language model. And the other one is this translation of natural text into our query language, right? So that kind of, a little bit from my point of view, a little bit two distinct use cases. The one is more, get me a summary, get me an explanation, an easy to read text such that I can navigate, for example, our documentation, that I can navigate another text. And the other one is more like code generation, all these code generation tools. And in our case, it's generation of our own invented query language. So the output is structured, is, let's say, testable actually, whether it's, for example, syntactically correct, whether it's semantically correct, whether it's actually executable by our database engine, by our data lake engine. So from that perspective, when it comes to testing, there are actually then two different approaches there. And one is this kind of, let's say, free text output, which you want to check, and to see whether the output of the system we built, of our Davis Copilot, is giving what you expected, right? It's not exactly as you said, and sometimes it does it a little bit longer, a little bit more longer paragraphs, smaller paragraphs, whatnot. Yeah, but as soon as it's close to your expectations, it's fine. But on the other hand, when you look at the DQL generation, it's a different thing. When it forgets one comma, right, it's not executable. So you need to make you may want to help the LLM there, in particular, to get the syntax right, and then also to get the semantics right. So and then also from what I have learned is that there is this whole life cycle of such a system which you build. It's not only the LLM, right? For example, our Davis Copilot is what you typically call this retrieval augmented generation approach, where under the hood you use an LLM plus knowledge sources, knowledge bases, right? Mm-hmm. Which you first. So you ask the system a question, then you try to find the relevant document text pieces in your knowledge base, and you pull out these relevant text chunks, and then you ask the large language model to give you a comprehensive summary of what was found in the knowledge base. That's this classical retrieval augmented generation. And so what you need to test is not only the LLM, it's the whole system. Right? It's more like an integration test at the end. Obviously, for each of the pieces, you can have your unit tests, but overall, it's an integration test there. And when you first started out with that, like when you start with this kind of chatbot thing, it's a little bit it's a little bit different than what I was used to do when I built, let's say, weather forecasts, right? Because you mentioned that I'm a machine learning engineer at Blue Sky, where we basically train each day many hundreds and thousands of machine learning models to predict locally precise temperature, energy production, humidity, and stuff like that. So typically numerical values. And for these numerical values, you have well-established KPIs for the quality of a trained model: root mean squared error, mean absolute error, R squared measurement, whatnot. While for this text output thing, those kind of measures had to be established over the last 2 years, while the others have been around for the last 50 years. Mm-hmm. So the community also went through a rapid development process of coming up with various types, how you actually measure those KPIs, whether an answer the system is producing is kind of close to what you were actually expecting. And this measure of closeness has also evolved over time with the availability of the measurement tools, I would argue. Right? As I mentioned, let's do a time travel again, and let's go back to 2012, for example, where most of the language modeling was done with, let's say, purely statistical models. And then back then also the measurement, whether a produced text and the desired text are close together, have been based on measures like you do tokenization, then you count how many tokens are equal, how large is the overlap of tokens, is the order somehow matching? So I don't know if the output is buy me some butter, for example, or whatnot, and the word butter in the expected output is in the first place, while in the expected answer it's in the last place. Even the same word is there, it's not the perfect match, right? You try to come up with all kinds of measurements from a statistical point of view, taking all these things into account. Let's say engineered KPIs. And then later on, as of now, then the LLMs came alive, right? They produce the text now, but they are now also used as judges to judge whether the generated text is actually that what you want as an output. So that's now a very common technique to use this, let's say, an LLM, which is more powerful than the LLM you're using to generate the output as a judge to argue about, is it faithful? Is the answer, is the output relevant to the found documents? So that's the question, whether it's faithful, or to avoid hallucinations, right? Mm-hmm. Because if the answer is completely off what you retrieved from your knowledge base, and it still is making something up, right? Then it's not the best, because why would I show you the facts, right? If you still ignore them. Yeah, exactly. That's about these. Let's say how you compute these KPIs nowadays. Mostly again with other LLMs or some, let's say, semantic closeness measures, which are also used in those in the search, the semantic search thing. Yeah.
Quick question on this, because this sounds like, we are, to explain it simply, we are creating digital twins of things we also have in human life. We have a teacher who is more, well, let's say an expert who is, better trained on a topic. And then we have, people that try to become experts. And then it's basically just like create an output and then I get graded by the expert. Right? It's like in pair programming. I have a junior developer and I have a senior developer and they do pair programming. And so with this, they kind of cross-check. I guess the only challenge is if we believe that these systems really always work, but if the expert is actually not an expert because the expert was trained on wrong data, then in the end, the whole system just doesn't really produce great output because it's, right? Maybe I'm thinking this wrong, but it's also in human
Andy,
life.
I was thinking the same thing, right? If you have, like, what's the data model that's being trained, that it's using to train, right? Because if you were to open it up to everything available on the internet and the deep internet, right, there's going to be a lot of wrong information out there. There's going to be a lot of right information out there. You might have answers that don't apply. Like you're Thomas, what you're talking about sounds like, okay, we're looking at the result, and is the report written correctly based on the information it used? But are the citations the wrong citations that it used? Like, yes, you created an answer out of what you pulled back, and that answer based on what you pulled back is written well. But the data you pulled from is bad, right? And how do we gatekeep that? The other thing I was thinking of, and I forget the name of IBM's one, the one that was on Jeopardy, right?
Watson, I guess.
What was it?
Watson? Was it IBM Watson?
Yeah, Watson. Yeah. And I believe that model is very similar to what I would call the Stack Overflow model, where people say this is the best answer, but then there's some other answers that may apply, right? And the devil is in the details, as you might say. This is probably the most common condition, but then there are some other ones that may or may not apply. And Watson, I remember when they were first talking about Watson, back when it was on Jeopardy, the idea was to use it in a hospital scenario. So a doctor can put in all this stuff, and it's come back 90% it's this, but these are some other conditions, right? So the doctor at least has a list to say, okay, let me go in order of what is most likely, but maybe it is going to be this thing way down here. And if we're only ever writing or returning an answer based on the top one and not considering the others, like how do you get that trust? How do you do that, do the gatekeeping of the data that's being pulled in? How do you make sure the data that you're building from, as Andy's saying, is proper data, right? Because again, most of the stuff it's learning from is coming from people, right? And people have opinions. And it's not even just the opinion, but there could be mass hallucinations among people, right? Everyone says, oh, this is the common thing. This is how you solve it, right? Someone else comes along, just like we have breakthroughs in technology to say, actually, if you make this little tweak, it's going to work better, you know? So how is that? I think, is that where you were going with this, Andy, as well? Because this was on my mind as this was being discussed. Yeah. Like, that seems like the harder part to gain the trust on.
I mean, what we do is, and what you typically do is divide and conquer, right? So basically, you described it already very well. It's to some extent, it's two different things. First, you need to make sure that you retrieve the right data. Yeah? And to ensure that this is working, we have built dedicated tests which measure the retrieval quality. So in this kind of tests, we have test sets in place. That's basically at the high level, that's the only approach in the whole machine learning community. You need a test set, right? Somebody needs to sit down and say, okay, for that particular answer, I would like to get these sources. For this particular answers, I would like to get these sources. And to make that reliable in our company, actually, we worked with D1 and support such that they give us for a user for the questions coming in from our customers, worked out RFAs, for example, and they said, okay, these have been the reliable sources we have been using to actually answer that question. And this kind of data source we are using to measure the retrieval quality and the retrieval precision. But then now it comes to the LLM. The LLM gets to see this, right, and the expected answer. And now we want to make sure that the LLM, how we build the system prompt, how we build the guardrails and things like that, that it actually reads that stuff and, let's say, summarize it in a way that we want. It should not be too short. It should not be too long. It should take the important part from there. And if you think about this classical summarization task, for that task, the LLM actually would not need factual knowledge, right? It would just need the capability of of a linguistically very well-trained person, which is perfectly trained in doing excerpt and text summarization. It actually does not need to have the capability anymore to look up stuff via Google or find something, or actually to understand at the very technical level what's there. It needs to be able to do this summarization task. And to some extent, that's, let's say, a different task than what is needed nowadays in all these agentic frameworks when it comes to reasoning and planning. So here you are pulling off from the LLM more this kind of linguist expert, which needs to do the summarization. And if you prompt the judge properly, you can kind of turn it into this kind of linguistic person.
Will we maybe end up in a world and thinking about, now again, our problem domain, observability. If I think about observability, we have many different personas who can benefit from observability to make better decisions, right? On the one side, it's the developer. They maybe look in the logs, into the traces. We have the tester that looks at, not maybe as deep into traces, but into other signals, into their, how the system scales, to some capacity planning. Then we have the SRE team, we have the deployment team and so on. Do you think we will end up, or does it make sense to train different types of models for these different types of roles we also currently have in our day-to-day life to really, and I'm using the word again, digital twin, which I know obviously is not a new word, but is this what we are ending? Is this where we're heading to, that we're creating smaller language models or smaller experts, digital experts on a certain problem domain, and then they can also talk with each other and argue and like we humans do? Or
that's at least, let's say, the trend where the whole industry and community is going to, that you have this kind of experts. The question is how you build those experts. Let's say 2 or 3 years ago, there was many people were kind of fine-tuning these large language models to adhere to a task, to a domain, and things like that. But now with the advent of these reasoning models, where you give a model, let's say, a set of tools which is appropriate for their job, to build exactly that expert, right? Or to build exactly that expert. That's now another way to build those experts. You don't necessarily fine train a model on a particular task, but what is happening now with these models, which are general purpose built with high reasoning capabilities, and let's say planning what tools to use in which situation, is that you are trained a generic expert when he reads the manual, or let's say, when he reads the manual of 5 tools, he immediately becomes an expert in using these tools. And that's how you nowadays are going to build these kind of experts. And this is what this whole agentic AI is about. That you have let's say a generic brain where you easily can attach any kind of tool, and this generic brain immediately reads the manual of each individual tool and a small manual how they are best used together, and then it immediately knows how to work with these tools. And yes, there's also companies or leaders in that space saying that then for let's say narrowly focused agents, that the brain which controls the tools must not be the biggest. It's not necessary that it is the biggest brain. It can also be a smaller brain which is fine-tuned how to use this set of constrained tools, right? But that needs to be shown from my point of view, whether this holds true with the rapid development of these general purpose models.
I think this brings up another important question with the data, right? Two observations on what you all just said. First of all, Andy, I think one of the dangers of the idea that you brought in would be, do we suddenly go back to siloed AI, which is what we've been trying to get away from within organizations with people, right? People who are completely siloed in their area of expertise, and then there's not the crosstalk. And that's one of the things I think observability and the whole DevOps movement helped bring about, is getting people talking with each other. So however that is, whether they're built silos but they communicate, or it's built not too small, we don't want to get too granular on the size of it, but we don't want to get full Copilot or ChatGPT size where it's got everything, right? And going back to the idea of the data feeding it definitely feels like I feel like it would be important for these tools to not only say this is what I'm built for, but to have a list of all of its sources of data along there published with it, right? Because one of the challenges you can run into is if you have whoever's in control of the sources of data controls what the output is, right? And not to get political here for a moment, but if you follow anything that's been going on in this country, we have like organizations like the CDC where they're scrubbing all this data, and some of our states, in terms of vaccines and all this kind of stuff, when we have a coalition of states that are sort of rebelling against that to keep true medical stuff alive versus the government sources. But traditionally it was always the government source of data was the official. So if you have people swapping in and out data sources for their agendas anywhere, right? It could be anywhere. I'm not just picking on us. I'm just using that as an example. That's where it can get, if it's too broad of a model, right? That's where it can get into a danger zone, right? And that's where you can have bad actors manipulating that data that's going into it. Like, I don't see how this would happen, but can you see, could there be a way that AWS would want to position its solutions as the proper ones versus its competitors, and can it manipulate things, right? I'm sure all that stuff will come up. So having those smaller models, but also publishing what the data, making public what the data sources are, I think would be critical to this trust of, is my answer a reliable answer? If I can see the sources that are being used and say, okay, these are non-political sources, these are non-special interest sources, whether it be for a company or for a government or anything. Because again, if you just use the super big ones, if you just went to generic public Copilot, you're going to have way too much data coming in. So I really do like this idea of having some sort of smaller size, but maybe not micro. I don't know if that makes sense. If this is stuff that's,
I mean, in general, this question where to cut systems and put trust boundaries, it's like in the same thing in software engineering all over again. How do you where do you put the system boundaries? Where do you put your module boundaries, your package boundaries? How do you structure the overall system, right? And yeah, I think what we will see in 10 years, nobody will knows today. That's my take. But I still trust the divide and conquer approach. So, and when it comes to this, let's say to this whole modularization and data and talking to data and talking to each other, because at the end it's not yet decided whether this in context learning, so how you prompt LLMs, or in the long term, the full, let's say, always need to train, so the need to train from scratch thing. And as far as I see the situation, this pre-training is more like learning the general skills, but the factual knowledge you can Google always, right? You can Bing it always. You will find it, and then you need just to interpret it. And this is, as of now, still something which stands true, except in 3 years we end up with retrained models every day. So I don't know if they can make it. But other than that, there is always still this analogy that a child is developing. That's the training phase. And then if it's trained, it has Google and Bing and whatnot, and it can pull in the facts, but then it has to be trained how to deal with these facts. And the question, how to polluted your brain is how you interpret the facts. That's then what I think what you said, Brian. Then if you, let's say, got trained in Austria to be a farmer, I'm just saying something, right? Then you will interpret the facts differently as if you were trained in, I don't know, in San Francisco being a, I don't know, software developer, right? And so this data lineage and how the training actually takes place and in which direction the large language model has been aligned to react to, right? These are these major training steps in all these large language models, where you have first the language training, then you have this reinforcement learning with human in the loops, then you have the, let's say, the next goal adjustment trainings, so to say. I also think that there is the danger with all these very big players which you don't get the details, right? They don't provide their data lineage. They don't provide all these fine-tuned all these very narrow details, how they actually do their fine-tuning. So I would agree that it would be very cool to have an approach where you actually can download a model based on what background knowledge you like to have in that model, right? You say, okay, I would like no biases into this direction. I don't like background in, I don't know, astrology, just saying something. Please keep that out of my brain, right? And make me the new data I receive interpret in this or in that way.
Yeah, I got one more question. Sorry, Andy. I know you probably got a lot of questions, but a lot of stuff's been coming up in this conversation. What about feedback loops for input, right? So if you get some good answers from AI, like, thinking about it in tech, right? I have a problem. My model is going to suggest I do X, Y, and Z to correct my problem, right? I go through, some of that works, but I find I had to make a tweak, and there's this one thing that was different than what the model gave me, right? How does that feedback go back into the model so the model can learn from that, right? And how critical is that? Because it seems like a lot of what the AI is learning is based on what exists, But then as we implement things, it's not getting those updates of what these changes are. If somebody publishes a paper or pushes into something, yes, the AI can learn from that. But how do we tackle the issue of it needs that live feedback? It needs to see this worked with a minor tweak in this case because of this little other variable that the model can learn from and consider.
That's to be considered on can be considered on very different scales, right? On the small scale, for example, on our generation of our DQL queries from natural language, you have the feedback button in the product, and if you give it a thumbs up or if you give it a thumbs down, you are asked what was wrong. And actually, then under the hood, we have our monitoring solution where we log all the prompts, everything which went wrong, everything which went good, with the thumbs up and down. And then actually we look into the data, into the generated DQL and take the mistakes, because sometimes it isn't able to generate it. And then we see, okay, it missed a comma. It was not very sure about how to use the join command, just saying something. And then we take this into account and place these improvements in our, so to say, in context learning. But as of now, this doesn't go back to our LLM provider. It still makes the same problems, but we correct it via in context learning. The other thing is, if you go to an OpenAI API, you don't get these, let's say, enterprise SLAs. You cannot opt out from prompt logging, so they will log everything. And when you then use GitHub Copilot, for example, and you give it a thumbs down or you don't accept the code proposal or whatnot, then all this information goes back into their servers and they will leverage it for the next training. So depending on your settings, whether you turned it off or not, the information, the feedback you're getting from the LLM making a failure can enter the improvement chain at various levels, really down to the next retraining or the in-context learning as we do it now for our product.
So the lesson there is everyone give feedback if it doesn't work, because if you're not giving that feedback, you're not going to get it to improve. That's great. Thanks. All right, Andy, I know you have a bunch of questions too.
Just a couple of quick thoughts, and I know we get into the end, but maybe some thoughts also for a follow-up conversation, because Thomas, I think we want to have you back. Couple of thoughts that came up. First thing is the discussion earlier reminded me of a podcast we recorded the previous session with Pini Resnick, because he talked about the transformation from cloud native to AI native. And he said, where we are right now, defining what AI native is like back in 2014, if you would have defined what cloud native is. Because back in the days, there was a new technology, containers, orchestration, Kubernetes, but people were just repackaging their apps and putting it on Kubernetes, but this is not cloud native. It wasn't cloud native, at least the way we see it today. So there's still a lot of things I think we have to learn what cloud native or what AI native is. And I feel like if we're just trying to model AIs based on the world as we know it right now to help us, then maybe we miss the opportunity to really redefine everything, because we don't need to just model the world we live in right now digitally, but maybe there's now an easier and a different way, right? Because why do we still need a developer, an SRE, a performance tester? Maybe we need something completely different thanks to AI. So that's one of the thoughts that I had. And I had so many other thoughts, but I think this was the most dominant one. Just trying to figure out. Oh yeah, the last one is right now, and this is true whether I have an AI or not. If I want to use an AI, I need to know what question to ask. If I'm a software engineer and I don't even know that I can ask for logs, because logs is where my critical details are about problems, then what does an AI help me, right? And I think this is also why we see, I guess, the move towards these agentic systems where I don't start prompting, but I have basically a digital assistant next to me that gives me proactive hints on also things that I've never thought about because I've never learned about these things.
It's these even autonomous agents then at the end, right? And I mean, from the very high level, it's a little bit like if you enter our product, right, and you have the health status on the front screen. You didn't even look. You didn't even ask whether there is something. You just saw that there is something. You already get informed. And now with these large language models, we probably can transform this into something different than a traffic light, red, green, yellow, but give direct insights, direct impact analysis, more tailored to human senses, I would argue, or to human communication channels. Language is still one of our most prominent communication channel, where you actually communicate logical steps, right, and things like that. So there is a big of an opportunity if you bring the word autonomous to the agent.
Yeah, exactly. And ideally, the agent also knows who I am and what I typically do. And then it doesn't bother me with data that is interesting, but doesn't help me right now. And it's focusing more on things that help me right now. Right. But I think the magic is I don't want a prompt. I want to get information that helps me to make the next right decision in my day-to-day job. Yeah. Hey, Thomas, I know we are all running close on time because we all have other things to go to in the next couple of minutes. What I would like to encourage everyone that is listening to this podcast, as always, there are links that on the one side, you had a presentation at a Java conference earlier this year. You had this Ask Me Anything session on LinkedIn. All of the videos are there. I can really encourage you to check this out to learn on how we at Dynatrace are leveraging this technology, what the architecture is, our testing considerations, also the whole topic of how we are monitoring it and seeing adoption and learning from this. So this is why we could probably talk for a much longer time. And Thomas, the world is not standing still. As you said, a lot has changed over the last 30, 40, 50 years, even longer. And I'm sure you may not look like 21 anymore, and I know you're not, but even in the next years, you will still be around. And I'm sure we want to have you back because you are much more in this topic and we can learn from you. So this is an open invitation to come back.
Thank you, Andy.
Yeah, absolutely. I just want to thank you also for being here. I think this is our third AI-based podcast in a row, potentially, although it's hard to keep track. There was that one I missed. But I think this is very, very interesting topics. And there's what we hear of about AI in the news, and then there's what we're learning about the reality of it on these kind of conversations. And you could see the big gap, right? If you take what you hear in the news, it's like, oh, AI, I'll give you all the right answers and it's good to go, right? And then we have these conversations and it's like, well, yeah, it's really helpful and it's making great strides, but there are these other factors, all these different things that people are working on to make it more trustworthy, to make it more accurate, to find better use cases for it, right? I think this agentic stuff is really fantastic. Those kind of use cases versus, again, create an image of these two people, right? That it's kind of like the novelty AI stuff versus the meat and potatoes AI stuff. So really appreciate you. Hopefully we'll have a Ask Me More session with you. And I hope our listeners are getting a lot out of this because it's I'm learning a ton, right? And I'm sure you are, Andy. And hopefully our listeners are learning a whole bunch from this also. Really appreciate people like you coming on, Thomas. Thank you very much.
Thank you.
All right, until our next episode, everybody. If you have any thoughts or ideas for episodes, if you're finding this AI stuff good, go ahead and send us an email at pureperformance@dynatrace.com. Love to hear your thoughts or ideas, especially in these AI topics. I think this is like a really big place, and it does still fit in with performance to a degree, but it's also everywhere now. So, yeah, that's it. Thank you, everyone. Bye-bye.
Thank you. Bye.